Okay, guys, we're going to try and work through this problem. It's another practice problem, which is very similar to the last one we did today. First thing I'm going to do is extend this page if I can. Alrighty, and then move back up, and we should be able to write down all of our known information. So if a child is throwing a 0 point, sorry, that should be mass. 1 second here. Mass equals 0.50 kilograms. It's a pretty heavy snowball, but that's okay. The initial velocity is equal to 12 meters per second. But the snowball lands on the ground in front of his friend. Remember, whenever something gets to ground, that means the height is 0 relative to that position. Now, a trick I could give you on a test tomorrow would be to make something other than the ground 0. Remember the table question. The table, relative to the table, the potential was 0. But relative to the ground, the book could fall off the table to the ground. So make sure we set our zeros appropriately. But in this case, the ground will be 0, and it hits the ground. So the snowball threw from, so H initial was 1.3 meters up. H final we know, because I just talked about the ground, is going to be 0 meters. I'm guessing, I haven't checked this yet, but they'll probably ask me to find what the final speed is, because I have initial speed here, and I have, or initial velocity, I have initial height, final height, but I don't have a final velocity. So I'm guessing that's what's going to be up, but I'm not sure. What is the total kinetic energy and what is the potential energy of the snowball at time of release? So that's initial. So E K initial is going to be equal to 1/2 mv squared, but because it's initial kinetic, that's got to be the initial v. We have all the information we need next to me here, so I'm going to sub it in. 0.5, so half times a half is a quarter, times 12 squared equals, bear with me, 0.5 times 0.5 times 12 squared. I get 36. I get, sorry if I can find out where I am here on my pad, 36 meters per second. Okay, gravitational potential, e.g. initial, is equal to mgh, but again this is the initial, so it's got to be I, so it's 0.5, 9.8, and height initial is 1.3. That equals 9.8 times 0.5 times 1.3 equals 6.37. 6.37. So let's go over here. Extend this page again. Okay, B, what is the total energy at the time of relief and just before it hits the ground? This is the same as what we looked at before. The energy total, whether that this is, we named it as the total mechanical energy, mechanical energy because we didn't talk about energy lost to heat or anything like that. So energy total or energy mechanical is equal to both. It's the sum, the total energy that it has, plus the total potential, which equals in this, sorry, I wrote down meters per second. It's joules. Energy is in joules. Sorry about that. 36 joules plus 6.37 joules is equal to 42.37 joules. Because energy is conserved. Again, if I asked you this on the test tomorrow, you got to tell me what the law of conservation of energy says. It says that energy is not created or destroyed, it merely is converted, and total energy is constant at all points in a system. So in this case, because energy is conserved, there will be the same E total at the end. Okay, so that takes care of that. What is the snowball's kinetic energy just before it hits the ground? Well, assuming that the total doesn't change and is equal to the kinetic plus the potential, as it falls, the height gets lower, but the speed gets faster because it's falling, so it accelerates. So the total of this EKG is equal to 1/2 mv squared plus mgh. Now, just before it hits the ground, this basically becomes 0. And if that becomes 0, let's change our color to red for one quick second. This whole thing becomes 0. And so all of my energy now becomes kinetic. So 1/2 times 0.5 times v squared, because I don't know that yet, but I do know the total energy is the same no matter where it is 42.37. So that equals 42.37 divided by, now I'm just going to multiply 1/2 times 1/2, gives me 1/4, which is 0.25, equals v squared. Let's move this up over here. Square root of 42.37 over 0.25 is equal to v squared square root, which is equal to v, which equals, the speed is going to be 2.37 divided by 0.25 square root 13. 13.02 meters per second. You give me a therefore statement for that, but I'll just do that. So it gained about a meter per second was that answer. And what was the last? How fast is it moving? Oh, I did C and D together. How fast is it moving? 13 meters per second. And so that's how we work through that. Whenever you do these problems, the total energy is always the kinetic plus the gravitational potential, and then you just have to figure out what point is it, how much is it. And like I said, I'll probably give you a question like this where the h goes to 0, but I might give you one where it doesn't go all the way to 0. So let's say it starts at 3 meters, like a kid falls out of a tree. Maybe I'll give you that question, it'd be a pretty good one. What is the kinetic energy if he falls from a branch that's 3 meters above the ground and falls down and grabs a branch just at 1 meter above the ground? How fast were they going when they hit that? You would do the exact same calculation right here. You would add these together and you would just change this h from whatever it was initially to the next h. And the total energy you had at the beginning is going to be equal to the energy at any point. So that might come up. I may do one like that as the final question, but you'll definitely see questions just like this. But I may ask you to find the mass or something like that. But probably the speed or the height are the two ones that you solve for if you're given the other one. Okay, so that's how you do that. Next question. Up here it says state the form of energy described. So we just have to identify it. This form of energy is possessed by charged particles. Charged particles would be electrical potential. They have the potential to discharge. A raised object is gravitational. Potential, so that's A, that's B, C. This form travels by waves. It's called radiation. D, something that is stretched or compressed. That would be spring. So that would be called elastic potential. Radiation is things like light and sound. Elastic potential would be springs and elastics and that sort of thing. This one here was for Tom. Tom, what we want to do is, I just need to know, you're doing the same as the last question, except you would just draw me a series for these things. So if I put this down, nuclear power plant uses, so the power plant, I'm just going to say PP, power plant, converts energy. I guess it depends on how intense you want to go. This is nuclear. Converts, and here's where it goes. You could tell me that it converts to thermal energy, which is heat, which then causes steam to power a turbine, which converts to kinetic energy, which turns around, which then turns a generator through a magnetic field, which generates an electrical current, which goes to electrical. So we could put nuclear, converts to thermal, converts to kinetic, converts to electrical, but I'd be fine at this level if you just told me that nuclear becomes electrical, because I don't know how in-depth we went on how that works. The electrical then goes to the TV, or to our house, which has the TV in it, our outlet, and that TV converts electrical to light and sound, which is radiant energy. It also, if you really want to get really good, and heat, because your TVs make heat, especially old ones, that's called thermal energy. Okay, so that's what that one does. Lettuce makes sugars you eat. So lettuce absorbs light, which is radiant, makes sugar, so that stores chemical potential. Me, I eat it, so I just convert the chemical potential to move. I convert the chemical potential energy into kinetic, because I move. And this one you have to know, because when you walk upstairs a lot, you're going to sweat. You'll also get heat or thermal energy, and so that's what you guys do. Just kind of make me a little chain here. So it's the same as the last one, you just have to do a chain. Last one, propane cooks, so we have, I'm not going to write everything, but the chemical potential of the propane is changed into thermal, which heats the grill, which goes into the hamburger or whatever you're cooking, which is also thermal. I guess I put the thermal in the wrong spot. I should have one arrow. The barbecue goes into the hamburger. The propane releases heat, which heats the grill, which then cooks the hamburger. So that's all I'm looking for, something like these. It's just kind of, excuse me, I'm tired. Sorry. It's the same question up here as identify the form. You just identify the form as it gets converted through. So that's that. So hopefully that helps. If I were you guys, I would attempt that quiz again, and any other questions that have answers. You've done these 3 questions. I mean, honestly, there's not too much more that's going to be there. If you can do this, you should be able to get 75–80%. And I'll give you one problem like that first one, like this one here. Sorry, like this one here, where I might not use a 0. That's really the only trick that I would throw it your way, and it's not really a trick. You just have to plug in the right H. It just may not be 0. You could go from 1.3 to 0.7. It wouldn't go to 0, but it's the same idea. All right. You can email me if you have any other questions. Hopefully I'll get them. If not, I'll also take questions before you guys start your test tomorrow. Good luck.